Hello, today we're doing an extension of lesson 3.3 called linear programming. Linear programming is an application of systems of inequalities. Our goal is to use linear programming to solve problems. To do so, we graph the constraints of the problem and determine the optimal solution for our objective function. I'm going to talk about what all these mean as we go ahead and do a problem. So first, we're going to sketch a graph of the system of inequalities. We're going to find the points where the boundary lines meet. We're going to evaluate the given equation at each of those points to determine the minimum and maximum. So this is an example without a word problem application. So what we're going to do is we're going to take these four inequalities and we're going to go ahead and graph them. So on my graphing calculator, we're going to put this one in, and we're going to go ahead and get y all by itself on these two. So this one, we're going to subtract x on both sides. And then we're going to divide everything by 2. So I'm going to put this on my graphing calculator, and then I'm going to go ahead and do the same thing down here. I'm going to subtract 3x on both sides. Divide everything by 2. Okay, so I'm going to put these four inequalities on my graphing calculator. Let's go ahead and do that. All right, now be careful. Let me show you something. On your graphing calculator, in order to put the x is greater than or equal to 0, we're going to go up to this x equals button and we're going to hit enter. Now we have x as our variable. So I'm going to do alpha greater than or equal to, which is alpha f4, put in 0. Make sure that's the only one you have. Go back up to the corner where it says y equals now, and we're going to put in the rest. Look at how I put mine in. I made sure I had the correct inequality. I made sure I used parentheses around my fraction. I used a negative sign instead of a minus sign. When that is all done, go ahead and hit zoom 6 to go to your graph. And if I'm going too fast, please pause the video. I want you to try these steps with me on your graphing calculator. Hit alpha F1 and number 1 because we only want to shade the intersection so we can see it. Now, what we need to find are all the points of intersection. So we need to find this point, this point, this point, and this point. I think you know what this point is. This point is 0, 0, right? Now, a quick way to do that, yes, you can go ahead and do your second trace to go to intersect and find all these and bounce around. But a shortcut, what you can do is you can hit alpha trace. So if I hit alpha trace and we bounce around, see where my cursor is blinking? It's telling me that point of intersection is 4, 6. So nothing's happening when I hit the up arrow. Oh, there we go. I went down to this one, which is 8, 0. And one more. 0, 0, we got that one. See, I'm hitting left, I'm hitting right, I'm hitting up, I'm hitting down. Trying to get it to bounce over to this one. There it is. 0, 12. No, that's the one way up there. That's why I can't see it. Should be able to get there though. See, it takes a little bit of playing around with. I believe it's 0, 8. There it is. See, it took a little bit for me to get that last one, but I got it. 0, 8. Okay, now we're going to go ahead and go back to our notes. Now, what do I need to do with this? We have an objective function. We are going to plug these points in to find out which is going to give us, in a word problem, it's going to be the most money. So I'm going to plug 8 and 0 in. So 2 times 8 plus 5 times 0, get 16. Now I'm going to plug 0, 0 in. So we get 2 times 0 plus 5 times 0 is 0. And then 4, 6, 2 times 4 plus 5 times 6 is what? 38. And then 2 times 0 plus 5 times 8 is 40. So we're going to look at these numbers, and we know that 0.08 is going to be our maximum, and 0.00 is going to be our minimum. So when it asks for the min and max, you would plug it in down here. You would actually talk about the point. So the minimum point is 0, 0, and the maximum point is 0.8. Okay, now I'm going to show you how this all applies to a word problem. Okay, a potter wants to make and sell serving bowls and plates. So bowls are going to be our X, and plates are going to be our Y. A bowl uses 5 pounds of clay. A plate uses 4 pounds of clay. The potter has 40 pounds of clay and wants to make at least 4 bowls. The profit on a bowl is $35, and the profit on a plate is $30. How many bowls and plates should be made in order to maximize profit? So let me make this a little bit smaller so we can see this. Okay, what I usually like to do is I like to write my profit equation. Once I write my profit equation, I can eliminate something. So I know it's going to be $35 on a bowl and $40 on a plate. So 35x plus 30y, because we called our bowls x's and our y's plate. How many bowls? Well, it says at least 4 bowls. Usually that's 0. Okay, but when it says at least a certain number of something, then we're going to have an actual number. How many plates? It doesn't say. Well, we can't have negative, so we know it has to be greater than or equal to 0. So we're done with that. Now, what didn't we take into account? The amount of clay. So a bowl uses 5 pounds of clay. A plate uses 4 pounds of clay, and we only have 40 pounds, so less than or equal to 40. Now, I know I need to put this on my graphing calculator, so I'm going to go ahead and rearrange this. Once I rearrange it, I get this. Oops, this is 5/4 x plus 10. So I'm putting this on my graphing calculator, this on my graphing calculator, and this on my graphing calculator. Let's go ahead and do that. Now remember to go up to the corner to put your x equals in. This time, remember, our x has to be greater than or equal to 4, which it's not, so let me fix that. There we go. And we want to check to make sure we have our y's correct. Go to Zoom 6, eliminate the shading by doing alpha shades, 1, and then you're going to hit alpha trace and bounce around with the arrows to find your points of intersection. I would like you to go ahead and try to do that on your own. I want you to find all 3 points. We're looking for this point, and this point. Go ahead and do that. Pause the video, and then we'll come back. Okay, so this is just those that want to sketch it. So you should have gotten your points to be 4, 0, 4, 5, and 8, 0. We are going to test this into our profit equation. Remember, our profit equation was 35x plus 30y. So we're going to plug 4 in for x, 0 in for y, and you are going to find out that you get 140. You're going to plug 4 in for x, 5 in for y, you get 290. Plug 8 in for x, 0 in for y, and you get 280. Now read the question. It says, which combination of bowls and plates will maximize profit? So which one gives me the most profit? Your answer is going to be 4 bowls and 5 plates. Now, for the you try problem, all I have you doing, because I think the hardest part about this is writing the constraints. So what I have you doing is I want you to try writing the constraints. I gave you a little hint here. How many small sheds? So we know that's going to be x is greater than or equal to a certain number. How many large sheds? Y is greater than or equal to a certain number. How many sheets of drywall? It's going to tell you about the drywall. And how many studs? It's going to tell you about the studs. So these two are going to have an x and a y in it. Okay? And then go ahead and write the profit equation as well. Any questions, comments, or concerns? Write it on the bottom of the paper, and I will see you tomorrow in class.